Today, first we will cover series circuits. What is a series circuit? If you have two components, they are connected like a head to tail. There are only one common node in between them. And to this common node, no other components connected to it. Then you can see those two components are connected in series. Like in this example over here, we have three components over here. Between 1 and 2, you have one node, and with this node, only those two components are connected to it. So they are in series, same as 3 over here. So actually, components 1, 2, 3, they are connected in series. Now let's consider the current in the circuits. Those three components are connected in series. So how about the current? Is there any difference of the current between each of them? Actually, consider there's only one loop. So current in one loop is the same. So they have same current. That is also to say, the circuits connected in series, each component will have same current go through them. This is an example. I use the FIT DC circuit construction kit to build this simple circuit. In this circuit, you will see I have a 9 volts battery and 3 resistors. Their values are 10 ohm, 100 ohm, and 10 ohm here. And what I did here is I inserted 2 ammeter to check the current at each location. You will see, since they are connected in series, both of them has 0.07 amperes. They have same current. In this example, I used a multisim to simulate 4 resistors connected in series. And in circuits, I insert 3 ammeter to check the current at each location. You can see each meter has a correspondence display over here, and they are same. So that is to say, if you have a series circuit, you want to check the current, then no matter where you put your current meter there, because they have same current. The formulas to find the total equivalent resistance is just to add them together if they are connected in series. So for example, those 2K and 3K are connected in series. So what's the equivalent? Add them together. Give you 2 seconds, you should finish. Okay, so the answer is here, 5 kilo ohm. Similar things over here. Yeah, you can see if you add those 3 together, because they are connected in series, so the total equivalent resistance will be 25K. And in this circuit, what's the relationship between the 4 resistors over there? If you trace the wires, you will see, okay, it's still connected in series. So since they are in series, just add the value together, you can get the total. Here are 2 more exercises you can do by yourself. And after you've done that, you will see, okay, in the circuit on the left, total is add together, so 25 kilo. On the right, total is still 25 kilo. Look at their location. On the left, you have 20K first, then 2K, then 3K. On the right, you have 3K first. So that is also to say, since they are in series, the order of them does not matter. You can change the order of the resistors. Their total value is still same. In this exercise, they want you to calculate what is the value of R4 over here. Let's see what they tell you already. They put an ohmmeter. Ohmmeter is to check the resistance. They put an ohmmeter from here all the way to here. And they tell you the total value is 18.7K. And you know those three. What is this value? Now consider the calculation. So this is like the total equivalent. Total equivalent is the sum of all of them. And you know three of them. How to find the fourth one? You need to use the total, subtract those three. So here's the answer. In this example, what we want to show is you have 4 resistors connected in series, and your power supply provided 12 volts. And over here, we use the voltmeter to check the voltage across each resistor. Look at the value over here. If you add the voltage across R1 plus the voltage across R2, R3, R4, add them together, what you should get? You can guess, you can use calculator to calculate. Your result should be equal to 12 volts. Because the total voltage from here to here should be the total voltage from here to here. They are same thing. Yeah, so here's also to say total voltage of source is the total voltage of the drop of the circuits that follow Kirchhoff's voltage law. Now we can find the equation of voltage divider. Okay, so first look at here, what's the relationship between R1 and R2? They connected head to tail. There is one node only connected to those two components. No other component connected to this node, so they are in series. Now let's think about if they are in series, how about current? We just mentioned if they are in series, the current will be same. So both of them has current I, suppose. Okay. And also, what is voltage over here? We talked about now the voltage drop from here to here equal to the voltage drop from here to here because the KVL. So V is equal to V1 plus V2. And based on Ohm's law, the total resistance of series circuit is R1 plus R2. Current is I, so the total voltage is over here equal to current multiplied R equivalent. Yeah, same current. So how about the ratio of V1 over V? We can check. Based on Ohm's law, what is V1? V1 will be R1 multiplied I. V, we just talked about, is over here. And then, since both numerator and denominator has I, we can delete it. Yeah, so equal to this. Similar thing for V2. So that way you will see V1 equal to V multiply this ratio. V2 will be V multiply this ratio. This formula is called voltage divider. The rule of this formula is if you want, if two resistors connected in series, if you want to know the voltage across R1, then the formula R1 on top, the total on bottom, multiply the total voltage, you will get V1, similar as V2. Okay. Yeah, so this is output voltage, input voltage. Yeah, V1, V2, you can consider that's output if you provide an input voltage over here. So this concludes the first section of Unit 7.